This exercise is related to electrical circuits, the Kirchhoff's law, the potential divider circuits, as well as the components in the circuits. I have already uploaded these assignments and the answer keys as well. When I'm giving you as a homework, don't try to check the answer key. You can check later, but don't try to solve by using the help of answer key. Once you submit, then you can check your answers from the key and then you can ask your doubts and you will learn from your mistakes. The battery, the first page number 4, a battery of electromotive force EMF is 9 volts and negligible internal resistance. So usually we neglect the internal resistance. So if a battery is EMF 9.6 volts, so in reality, in practical, it won't provide us the 9.6 because when the current start to flow, that the battery will not provide 9.6, the battery might provide 9.4 or 9.5. It won't be 9.6 because some of the voltage loss internally. But in the question, we always ignore this. And usually in exam, if the battery is having an internal resistance, then they will provide you a symbol with a battery with internal resistance. It's always like this. So it's a 9.6 volt supply or EMF, the maximum it can provide us. And we have two resistors, 3400 ohm and 5800 ohms. And there's a thermistor connected in the circuit. The fixed resistor have a resistance of 3400 and 5800. The reading on the voltmeter is 6 volt. So if the reading on the voltmeter is 6 volts, so 6 volts here. So how much voltage will be across this one? So the circuit, actually the circuit is like this, that the two resistors are connected in series, the thermistor and the fixed resistor. And another one is also there in series. This is 5800 ohm. And the voltmeter is actually connected across these two. And this is 6 volt. If the total is 9.6 volts, this is 6 volts. How much voltage will be there across a 5800 ohm? So the remaining will be there. So it means this will have 3.6 volts. And the total current in the circuit will be same because they are all connected in series. That's why the total current will be same. So the first part, calculate the current in the 5000 resistor 5800 ohm. So the current start to flow, the conventional current, and it will be same current as they are all connected in series. The voltage across this part is 6 volts. So the remaining voltage will be 3.6 volt. If we have a voltage and we have a resistance, so we can use Ohm's law, V equals IR, where V is the voltage, I is the current, and R is the resistance. So what potential difference we'll take? We'll take 3.6. And whenever you're solving a question in physics, always write a formula. So 3.6, I is a current which we don't know, and R is the total resistance of that component, 5800. So if we need the current, so 3.6 divided by 5800. How much is the current? 6.2 exponent minus 4. Okay. So 6.2. So 6.2 raised to 10 raised to power minus 4 an ampere. Or if I want to convert into milliampere, I can say it is 62 milliamps. But that is also fine. The total voltage is given to us, but the problem is we cannot find the total resistance of the circuit. Why we cannot find the total resistance of the circuit? Because this thermistor resistance is unknown. As a thermistor resistance is unknown, that's why we cannot use a formula we cannot use a formula V is equals to IR and V substitute 9.6. I you are finding. R is also unknown here. Why R is unknown? Because the thermistor resistance is not known to us. That's why we cannot use that formula. That for a total we cannot use. That's why we just use for the section of the circuit. Calculate the resistance of the thermistor. How we can work out the resistance of the thermistor? Now we have the current. There are different ways you can work out. You know the total, like we have the formula. Now you can use V is equals to IR. V is the total voltage, which is 9.6. I is the current. The current here was 6.2 into 10 to the power minus 4 ampere. And actually, that is the same current. That is the same current throughout the circuit because they are connected in series. So this will be 6.2 into 10 to the power negative 4. So this is R. So 9.6 divided by 6.2. This is the total circuit resistance. 6.2 exponent minus 4. What's the answer here? 9.6 divided by 6.2 exponent 4. That's the total resistance of the circuit, which is 15,500. So the total resistance of the circuit is 15,500 ohm. And out of this, because they are all connected in series, so the total resistance will be equals to sum of 3,400 plus the unknown resistance of a thermistor we call X plus the resistance of this one 5,800. We just need the total resistance is 15,500. So 15,500 minus 3,400 minus 5,800. That will give us the value for X. What's the answer here? 15,500 minus 3,400 minus 5,000. So 6,284. So the resistance of the thermistor is 6,284 ohm. 6,300. Okay. 6,300 ohms. That is the resistance of the thermistor. So it is 15,500 minus 3,400 minus 5,800. When you subtract, you are getting 6,300 ohm as a resistance of the thermistor. The next is the internal energy stored in the battery. The battery stored 2.6 exponent 4 joules. Assume that the EMF of the battery is constant. Determine the final energy stored in the battery after a charge of 3,300 coulombs has moved through it. Because the battery is having a chemical energy and it is converting the chemical energy to electrical energy. We want to find how much energy is left in the battery once it has transferred this much charge. So the formula to find the energy, there are different formulas to work out the energy. Energy is power into time. In electricity, we have different formulas of the power. P is equals to VI. So energy will be VIT, or if we can use I square R, so this will be I square RT. And if we use V square over R, then it will be V square R over T. So the energy supplied by the battery, we have the formula voltage is work done per unit charge. That's a formula for a voltage or the potential difference, you can say. So if I want to find how much work is done on the charge, so it will be voltage into charge. So voltage into charge will be equals to work done. So the voltage was 9.6 and the charge was 330. So how much work is done on the charge or how much energy is used to push the charge? That is 9.6 times 330. What's the answer for this? How much work is done on the charge? So 3,106. So 3,168 joules of work is done on the charge. Why VIT is not working here? Because we don't know the time. That's why energy is power into time, but the problem is time is unknown. That's why we cannot use this formula. In the question, they did not provide us the time. If they give us like 3,300 coulomb of a charge is moving in 5 seconds, 15 seconds, 2 minutes, then we can use any of these formulas. So this is how much energy supplied by the charge, supplied to the charge. 3,168 joules. And what was the original energy stored that was given in the question, that the battery was having 2.6 exponent 4 joules of energy. So if 2.6 exponent 4 joules of energy was there originally, and it has given 3,168, so how much energy is left in the battery? That was a question. It's not like how much energy transfer. So what we do, we'll just subtract. So 2.6 into 10 to the power 4 minus 3,168. What's the answer for this? How much energy is left in the battery? So 22,832. So 22,830 joules of energy is left in the battery when it transfer 330 coulomb of a charge. Is it clear, this one? Next, we have the environmental conditions change causing an increase in the resistance of the thermistor. State whether there is a decrease, increase, or no change to. So if the resistance increases, so what happened to temperature? We know thermistor is a semiconductor, and for semiconductor, heat and light are the forms of energies which produce more charge carriers and electrons. So as a result, what will happen to the resistance? The resistance will decrease if there is more light or heat. But in the question, its resistance has increased. If the resistance has increased, what will happen to light or heat? The light or a heat has decreased. So what happened to temperature? The temperature has decreased. And because the resistance is increasing, as the resistance is increasing, so what happened to the current? The current will also decrease. Because if high resistance, less current. But what happened to the potential or work done per unit charge? In a potential divider circuits, if we have a potential divider circuit, if one component is resistance is increasing, so the voltage across that component will also increase. But keep one thing in mind, student get confused with a parallel circle example. What if I was having a thermistor and a fixed resistor is there? Like let's say thermistor is alone without any other component. And there was a 10-volt supply. Even though in this example, if the resistance of the thermistor increase or decrease, the voltage here will remain 10. It won't change. Why? Because this is the only component available in the circuit. That's why the voltage will not change at all. If it is only single component. But if there was a thermistor and it is connected in series, it is connected in series with another fixed resistor. If what will happen if the resistance of a thermistor increases? So more voltage across thermistor, in comparison, less voltage across the fixed resistor. If it's a 10-volt supply, maybe like 7 volts here and remaining 3 volts will be here. And if the resistance increases, the voltage across thermistor will also increase. And what happened to the current in the circuit? Because the combined resistance will be the sum of the individual as they're in series. So the combined resistance is increasing. So the current will decrease in a series circuits. But in a parallel circuit, if a thermistor is connected, with another component and it's a 10-volt supply, so this will also have 10, this will also have 10. Irrespective of what happened to resistance of a thermistor, even it increase or decrease, but that will not change because they are in parallel to the battery. But if it is parallel and there's another component connected, let's say there is a thermistor and a fixed resistor, and there's another component or a fixed resistor connected here. So what will happen if a temperature is decreasing? So the resistance of a thermistor will increase. If a resistance of a thermistor is increasing, so this resistance is R, this resistance is R, this is also R. So what happened to the combined resistance the combined resistance of a circuit when two resistors are like, if I have 100 ohm connected to 100 ohm, so combined resistance will be a product divided by sum, so it will be 50 ohm, half. But if I have, let's say this is 200 ohm and this is 100 ohm. So what is the combined resistance for a two product divided by sum? So 200 into 100 divided by 200 plus 100. So it will be 20,000 divided by 300. What's the answer for 20,000 divided by 300? The combination 20,000 divided by 300. So that will be 67. So means the combined resistance of the parallel will increase compared to originally. So here what will happen? The voltage will increase, and in comparison the voltage will decrease. So it depends on how the thermistor is connected in the circuit. Another question, page 6, define the potential difference across the component. You have to learn the standard definition. Don't write the definition in your own words, because these definition marks are the free marks. So if you try to write in your own words, you may lose the mark. So what is the definition of a potential difference? It is work done on a unit charge, or work done by a unit charge, not on you, because if it is work done on unit charge, then it will be EMF. So it is the work done by a unit charge when the electrical energy changes to other forms. And what is the EMF? EMF is work done on a unit charge when when a chemical energy converted into electrical energy. The variation with the potential of V and I in a semiconductor diode is shown. Use figure 6.1, describe qualitatively, means you don't have to calculate anything. The resistance of a diode from 0 to 0.25. What is the resistance in this part? We don't have to calculate here. The current is 0. If anything is divided by 0, you got infinity. So what is the resistance of this part? It's very high. You can also say it is infinite. And why it is an infinite resistance? Because the barrier does not allow any charges to flow across it. The variation, if any, to the resistance of a diode when a V changes from 0.75 to 1. So 0.75 will be somewhat here. So from 0.75 to 1, what we have a straight line. So if we have a straight line, if a slope is constant, or the slope is if a slope start to increase, the current and the voltage graph, if current is on y-axis and voltage on x-axis, slope is reciprocal of the resistance. So if the slope is increasing, the resistance is decreasing. So the resistance start to decrease. The slope is, when we take a 0.75 will be somewhat here. Because this actually the graph of the diode is always like this. So it's that for a very small section, it is a straight line. But usually for a diode, the resistance continuously changes. It continuously decreases because the conduction increases. So resistance of a diode does not remain constant at any point. So a battery, even if the question was what happened to resistance of a diode, even they said they change this value, like example 0.5 to 1, you will also say decrease. If they say even 0.8 to 1, you will also say it is decreasing. Because that small section is there, very small section, but it continuously changes the slope. It's not an exact straight line. But for a fixed resistor, it remains constant for a longer duration. A battery with an EMF of a 12 volts with a negligible internal resistance is connected to a uniform resistance wire X and Y. A fixed resistor and a variable resistor is shown. So 2.7 ampere is a current. 1.5 ampere is flowing through 5 ohms. So same will flow through a variable resistor and 2.7 will return. The total length is 2 meter and the length of this section is 1.6. Figure is not to scale, like you cannot use a ratio of the lengths from the figure. The fixed resistor has a resistance of 5 ohm and the current in the battery is 2.7 and the current in the fixed resistor is 1.5. Calculate the current in the resistance wire. So how much current will flow? So we'll use a Kirchhoff's first law that the current enter at any point, the total current enter a point will be equals to total current leave the point. That is a Kirchhoff's first law. So how much current enter, the same amount of the current will leave that point. Whenever you're solving a question, it's a 1 mark. So here the formula does not have any marks, but so you can say this will be 2.7 and the current out is 1.5 plus unknown X. So 1.5 will be there subtracted. You can directly write the answer for 1 mark question. You don't have to write a formula. You can directly write the answer. So this will be 1.2 ampere. Determine the resistance of a variable resistor. So if you want to determine, it's a similar type of a question we did the first one, that this is a 12 volt supply. This is a 12 volt supply. So how much voltage will be here? The voltage here will be 12. So what we can do, we can work out the voltage. We need the resistance here. We know the current is 1.5 ampere. So if I work out how much voltage is here, 5 into 1.5, because the ratio of the resistance and ratio of voltage is always same. So 1.5 into 5, so what we got? We got 7.5 volts. So out of 12, 7.5 volt is here. So how much is the remaining voltage? So the remaining voltage will be 4.5. So 4.5 volts will be across the variable resistor. Now we can work out the resistance using a formula V is equals to IR. So V, the current is 1.5 and the resistance is, the voltage is 1.5, sorry. Voltage is 4.5 and the current is 1.5. So we can find the resistance by taking a ratio. So 4.5 divided by 1.5. So the resistance will be 3 ohms. So this is 3 ohm resistor. The wire XY has a length of a 2 meter. Point Z on the wire has a distance of 1.6 from X. The fixed resistor is connected. Determine the potential between point W and Z. So we want to determine how much is the potential between these 2 points. If they were having the same potential, like the same voltage, it means in that case, the reading will be 0 on the meter. But now we want to determine what is the potential here between these 2 points. So there are different ways we can do this. What is the voltage difference between these 2 points? Like there will be some voltage here and there is a voltage at this point. We want to determine the difference in the voltage of these 2 points. Like we'll find the voltage here, we'll find the voltage here, and we just determine the difference in the voltage. That is what we have to do. So how I can work out the voltage here? If I remove everything, like I remove this section of, if I need the voltage here between X and Z, because what we need a potential difference between these 2 points, between W and Z. So what we'll do, we'll determine the potential across Z, we'll determine the potential across W, and we take a difference of these 2 potentials. That is what we have to do. So what is the potential here? We know the length. So I can use a potential divider formula, ratio of the voltage. If you just recall the potential divider formula, V1 is equals to resistance of that part divided by the sum of the resistance into combined voltage V. But if the lengths are given, I can take the ratio of the lengths. So length of that part divided by the sum of the length into total voltage V. So total voltage is 12. Length of this part, which is 1.6 divided by total length, which is 2, the total, into combined voltage, which is 12. What is the answer? 1.6 divided by 12 divided by 2 into 12. 1.6 divided by 2 multiplied by 12. How much is the potential here? 9.6. So we got the potential 9.6 volts is across W. Then we'll determine what is the potential. We'll determine what is the potential across the other one. We already did that. If you remember, like I worked out the voltage here. It was 1.5 and 5. So when I multiply, I was guessing 7.5 volts here. So means this section has a voltage of 7.5 and this section has a potential of 9.6. How much is the difference in the potential in these 2 points? How much is the difference in the voltage between these 2 points? So what we do, we just take a difference of these 2 points. So 9.6 volts here and 7.5 volts here. So how much is the difference in the potential between the 2 points? So I'll just subtract 9.6 minus 7.5. So that will give us 2.1 volts. Is it clear? So if I connect a voltmeter here, I will read 2.1. But if you recall, if we were having a same resistance of this part, if the same potential was there, let's say this was 9.6 and this also 9.6, in that case, the reading on the voltmeter which is connected here will be 0 because the voltmeter record the potential difference. That's how we got a potentiometer formula, that the ratio of resistance and the ratio of voltage will be same. The next is the resistance of a variable resistor is now increased. By considering the current in every part of the circuit, state and explain whether the total power of the battery decrease, increase, or stays the same. Now, what we did, we increases this resistance. If we increase the resistance, what will happen to the resistance of the circuit? The total resistance of a circuit, the total resistance of a circuit will increase, because if this resistance was R1 and this resistance is R2, the total circuit resistance is R1 plus R2. R1 is constant, but R2 is increased, so the total resistance of a circuit has increased. If a total resistance of a circuit has increased, what will happen to the total current which is coming from the battery? The combined current, like the total current, definitely it will decrease. Because even the fixed resistor and the resistors are connected in parallel, but this branch, this section has a high resistance. So if this section resistance increases, the total current which is coming out from the battery, that will decrease. Or the current in the branch will also, because we have to compare all of them. So what will happen as the total current which is coming out from the battery, the total current which is coming out from the battery has decreased, changed. So what will happen to the power? The EMF is the same. Like it has the same EMF and we have the power P is equals to VI. V is constant, but the total current is decreasing. If the total current is decreasing, the power will also decrease. So the power output from the circuit will decrease. Is it clear? So how you will score the 3 marks? 1 mark for mentioning that the current in the, like as a variable resistor, the resistance of a variable resistor will, the total resistance of a circuit will increase. So as a result, the current in the circuit will, the total resistance of a variable resistor and the circuit has increased. So the current in the circuit will decrease. If the current decreases, the power will also decrease because the voltage is constant for the same EMF. The current is decreasing, so the power will also decrease. Is it clear, this one?